Hello students. So today also we are going to solve some more problems on three areas. This is our second unit consists of three areas. As you know, one is torque, that is the torque on a magnetic dipole when it is placed in external magnetic field. Then second one, work done in rotating a magnetic dipole or short bar magnet in the external magnetic field, and third one is magnetic induction due to a short dipole, and another important one is our time period of oscillation of a dipole in external magnetic field. That is also, I told you, vibration magnetometer. That is the principle of the vibration magnetometer. Okay. So, now let us take this problem. A magnet is suspended at an angle of 60 degrees in an external magnetic field of 5 into 10 power minus 4 Tesla. What is the work done by the magnetic field in bringing it in its direction? Bringing it in its direction. The magnetic moment of the magnet is 20 ampere per meter square. Okay. So, what is the problem now? A magnet is suspended at an angle of 60 degrees. A magnet is suspended at an angle of 60 degrees. Okay. So, the question is, a magnet is suspended at an angle of an angle of 60 degrees in an external magnetic field. In an external magnetic field of 5 into 10 power minus 4 Tesla, in an external magnetic field of 5 into 10 power minus 4 Tesla. Right. Next, what is the work done by the magnetic field in bringing it in its direction? What is the work done? What is the work done by the magnetic field? Work done What is the work done by the magnetic field to bring the magnet magnetic field in its direction. Magnetic field to bring magnet in its direction. Magnetic field in its direction. Magnetic moment capital M of the magnet is 20 ampere meter square. 20 ampere meter square. So, the direct application of formula I told you already. Directly we have to apply formula here. So, for that solution. So, what is the formula for this? Work done equal to m into mb into work done equal to mb into so work done equal to mb into cos theta 1 minus cos theta 2. So, theta 2 is theta 1 is given how much? 60 degree. Here theta 1 is 60 degrees. But what is theta 2? What is theta 2? See the magnet, when you see this is magnetic field, uniform magnetic field. Now, initially this is the magnet making an angle 60 degree. Now, it is coming in line with the magnet. So, what is theta 2 now? Theta 2 equal to 0. So, theta 2 is equal to 0 degrees. Therefore, what is the work done? Just substitute the values. Just we will substitute the values. So, work done equal to m is given how much? M is given as magnetic moment is 20 into, now B is how much given? 5 into 10 power minus 4. 5 into 10 power minus 4. 5 into 10 power minus 4 into cos 60 minus cos 0. Direct substitution only. So, that is equal to how much now? 20 into 5, 100 into 10 power minus 4 into cos 60 1 by 2 minus 1. So, that is how much? Minus 1 by 2. So, minus 1 by 2. So, 100 by 2, that is minus 50 into 10 power minus 4 joules. So, that is the work to be done by the external magnetic field to bring the magnet in its own direction from 60 degrees to its own direction. So, this is a old MSET problem. This was given on old MSET and IIT also. Next one here, a magnetic needle lying parallel to a magnetic field require W units of work to turn it through 60 degrees. To turn it through 60 degrees. Okay. Then see this. What is the torque needed to maintain the needle in this position? See the problem here, both are combined here. Magnetic needle lying parallel to a magnetic field require W units of work to turn it through 60 degree. Okay. So, now what is the torque? What is the torque needed to maintain the needle in this position? Okay. So, now see the problem. A magnetic needle lying parallel to a magnetic needle lying parallel to. So, our problem is a magnetic needle lying parallel to a magnetic field a magnetic field requires W units of work, requires W units of work, W units of work to turn it through 60 degrees, to turn it through 60 degrees. See, so that part, one part. Next, what is the part here? Next part is here we have what is the torque needed to maintain, what is the torque needed to maintain the needle in this position, 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 right? Now, so first what you have to see, that first part, first he has given what is the work W units to turn through 60 degree, that we will write first. So here solution, for solution, first we will see that W is what? W equal to MB into cos theta 1 minus cos theta 2. That is our basic formula. Theta 1 is how much? First note down. Theta 1 how much? 0, because it is lying parallel to the field. And what is theta 2? It is given 1 by, that is given 60 degrees. Theta 2 is 60 degree, right? So theta 2 60 degree. So what is our work now? What is our work? W equal to MB into cos 0 minus cos 60. But cos 0 1 and cos 60 is 1 by 2. Therefore, what is that work? Work relation? W equal to MB into cos 0 degree minus cos 60 degree, that is MB into 1 minus 1 by 2. Therefore, that is W by 2. So what is MB? MB is equal to 2W, right? These are one relation. Now what he want? What he want here? What is the torque needed to maintain the needle in this position? Means what? At 60 degree we have to maintain. For that, what is the torque required? So what is the formula for torque? Torque tau equal to, we have MB sin theta, isn't it? MB sin theta. So how to write that now? We know cos value only. We don't know what is sin value. So what we will do now? We will write this as sin theta, we can write as 2 sin theta by 2 cos theta by 2. So this is equal to, we can write 2MB sin theta by 2 cos theta by 2. Isn't it? We know theta value. Theta value is how much? Here, what is theta value given? Theta value given as, or we can take ratio also now, isn't it? So we can take ratio now. C by W equal to, C by W equal to, we have 2 MB sin theta by 2 cos theta by 2 divided by W how much? How much we got? MB by 2. We got how much here? In place of MB by 2, MB by 2. Therefore, MB cancel. 2 will come to numerator. So that will be how much now? That is equal to 4 into this we can write like this also, no? Here what we have C by W, in this case we can write this as, this is sin square theta by 2, very sorry, here sin square theta by 2, no, this one, this is sin square theta by 2, 2 sin square theta by 2, sin square theta by 2, sin square theta by 2, okay, sin square theta by 2. Then what we will get here, in this case, when we take that, our C by W, this is sin square theta by 2, sin square theta by 2. So sin square theta by 2, sin square theta by 2. Then what is given here angle? The angle given is, so that will be now, when we divide that, W is equal to, here, not this one, we have to write here, this MB we have to write, because 1 minus, for easiness, we can write that. MB we can write, isn't it? This itself we can write, not this one. This we can't write. So this is equal to 1 minus cos theta, no? So 1 minus cos theta, we won't substitute the values. First we will take 1 minus cos theta. 1 minus cos theta. For simplicity, we take 1 minus cos theta. So 1 minus cos theta, we'll write it as 2 sin square theta by 2. Not this. This is not a mistake here. So sin theta, this is sin theta we can't write. So this is 2 sin square theta by 2. MB into 2 sin square theta by 2. Right. So into MB. Right. Now we will divide one by the other. Okay. So then what we will get here? 2 sin square theta by 2. Then we have tau equal to MB sin theta. Therefore, here we can write another simplified form. So this we can write in another way. That is here. Now this we will write MB again in simplified form. Right. Now here this we will write like MB into 2 sin theta by 2 cos theta by 2. Right? Now what we will get here? Now we will divide. Now we are going to divide. That is MB 2 sin square theta by 2 divided by what is our this one? MB into 2 sin theta by 2 cos theta by 2. So sin theta by 2, 1 square gone, MB gone, 2 gone. Then what we have? We have sin square theta by 2, sin square theta by 2 by cos theta, sin theta by 2, cos theta by 2. That is how much? Tan theta by 2. That is how much? 60 by 2. So tan 60 by 2, which is tan 30. Tan 30 is how much? Root 3, isn't it? So what is the work done now? Work done, torque equal to W root 3. That is root 3 W. Root 3 W. So that is only mathematical simplification, trigonometry. So here first unnecessarily I have done that, but we can write 1 minus cos theta equal 2 sin square theta by 2 into MB, and here we write sin theta equal to 2 sin theta by 2 cos theta by 2. Then we are dividing one by the other. So we will get finally tan 30, that is equal to root 3. Therefore, torque equal to root 3 times W. Okay. So that is our very important problem, very good problem also, that we can expect till M set. Okay. Please note down that. Then we will go to the next problem. A bar magnet has a magnetic moment 2.5 joule per Tesla, another unit of magnetic moment, and is placed in a magnetic field of 0.2 Tesla. Calculate the work done in turning the magnet from parallel to anti-parallel position relative to the field direction. Parallel to anti-parallel. See that. So first let us have a bar magnet has a magnetic moment. A bar magnet has a magnetic moment a magnetic moment 2.5 joule per Tesla. 2.5 joule per Tesla, and is placed in a magnetic field of in a magnetic field of 0.2 Tesla. Now what you want to find? Calculate the work done in rotating the magnet from parallel. Calculate the work done in rotating the magnet from parallel to anti-parallel with respect to the field. With respect to the field. See, that is very, very important here. With respect to the field. What is first one? See that first one. How is the magnet? See the magnet initially. This is our this is the magnetic field. So whenever nothing is mentioned, uniform magnetic field. Now, initially it is parallel to the field. Means what? Here, this is south pole, this is north pole. Now, anti-parallel. See, anti-parallel means what? Now it will be anti-parallel like this. This is anti-parallel. See the magnet now. Anti-parallel means what? Now it is coming north pole and south pole. So what is the angle turned? North pole, south pole. Anti-parallel. Right. So actually this anti-parallel means first we have to write. So yes, this is parallel and this is anti-parallel. Okay, means what is our theta now? Solution, we will take the solution here. What is theta? Theta 1, 0. What is theta 2? What is our theta 2? Theta 2 equal to 180 degree. So substitute in our formula. So W equal to, we can write MB into cos theta 1 minus cos theta 2. That is equal to M is 2.5 and B is 0.2 into cos 0 minus cos 180. So cos 180 is what? Minus 1. So minus of minus 1 plus 1. Therefore, it is equal to here plus 1. See this, I will write 2.5 into 2. That is what? 5. Right? 2.5 into 2, that is 0.5. 25 into 2, 50. 2 decimals are there. So 0.5. This is equal to 0.5. So 0.5 into 1 minus of minus 1, because cos 180 is minus 1. Therefore, that will be equal to 2, isn't it? Therefore, it is 1 joule. So the work done is 1 joule, right? Next one. So this is based on work done. Now we are going to the other side, that is our vibration magnetometer. So yesterday we have done one problem on vibration magnetometer. Now we will do few problems on that. A bar magnet makes 40 oscillation per minute in a vibration magnetometer. An identical magnet is demagnetized completely and placed over the magnet in the magnetometer. Calculate the time taken for 40 oscillation by the combination. Ignore induced magnetism. Ignore induced magnetism, because when a magnetic material is kept on a magnet, it will induce magnetism. But that is saying, don't consider that. Means what? It is just like a material, that's all, having same dimension. So in that case, we have to consider change in moment of inertia. So now first let us note down this. What is given here? A bar magnet makes 40 oscillations per minute. A bar magnet, so our problem is a bar magnet makes 40 oscillations in per minute. Oscillation per minute. So oscillation per minute in a vibration magnetometer. Next, an identical magnet is demagnetized. An identical magnet is demagnetized and kept demagnetized and placed over the magnet in the magnetometer. Placed over the magnet in the magnetometer. In the magnetometer. Right. Next, what do you want to find? Calculate time taken for 40 oscillation by this combination. Find the time to complete 40 oscillation by this combination. 40 oscillation by this combination. By this combination. So, by this combination. And he says neglect induction effects, induced magnetism, neglect induced magnetism, right. So, here as I told you, see that oscillation given, not time period. So, for that first we will see that we want oscillations only. That means frequency. We know here frequency equal to 1 by time period, isn't it? Circular motion, already first year we have seen F equal to 1 by T, that is 1 by 2 pi into square root of I by m BH. So, what we will get here? Now, we will get 1 by 2 pi into square root of m BH by I. That is our frequency. That is number of oscillation per second. But here answer is given in minutes itself. So, we need not bother about that units. So, what is this? M constant here. Same means magnetic moment is same only, because other one is a non-magnet and BH is same. So, only thing we have to consider is I. So, what we can write now? F is inversely proportional to root I. Root I, right. So, that means F2 by F1 equal to square root of I1 by I2. I1 by I2. So, for that, what is the time? Per minute. It is per minute. Therefore, this we can write square root of, first is I, second one, both of them together, no, identical magnets. Therefore, it will be 2I. It will be 2I. So, what we will get here? So, that will be equal to now, here we have that is F2 is equal to 1 by 2, no? So, F1 by root 2. F2 equal to F1 by root 2. But what we want here? We want time. So, time is what? Reciprocal of that. Therefore, T2 is equal to 1 by F2. That is equal to, we can write 1 by F2, which is equal to root 2 by F1, but 1 by F1 is T1. So, root 2 T1, that is root 2 40 root 2. We can write 40 root 2 per minute, minutes, 40 root 2 minutes, 40 root 2 minutes. Suppose they want answer is in second, just we divide by 60, then we are going to get 4 2 times, this is 3. So, that will be equal to 2 root 2 by 3 seconds. So second is given, you can convert into second. Minutes you can leave in minutes itself. Okay. So next one we have a short bar magnet oscillate in a vibration magnetometer with a time period of 0.1 second, where the horizontal component of Earth's magnetic field is 20 microtesla. An upward current of 18 amperes, upward current of 18 amperes is established in the vertical wire placed 20 centimeter east of magnet. Find the new time period. You want to find what is the new time period. This is a very good question which we can expect in MSET also. So here, but your moving charge and magnetism is over. So I will take another, I will take in after moving charge and magnetism. Now here we take one more. A magnet is suspended so as to swing horizontally, makes 50 vibrations per minute at a place. That also is not over for us. So next one, when a short bar magnet is kept in, so here, no, not that one. So one more. So we'll see, because they are all related to coming articles. So we'll take one more problem of level 2. We'll see level 2 problems. Yes, see this one. A bar magnet of magnetic moment M1 is suspended by a wire in a magnetic field. Okay. The top of wire is twisted through 180 degree. Then the magnet is rotated through 45 degrees. Under similar condition, another magnet of magnetic moment M2 is rotated through 30 degree. The ratio of M1 is to M2. So this is related to our torque, isn't it? So for that, just note down the problem here. First let us note down what is the problem given. A bar magnet of magnetic moment M1, a bar magnet of magnetic moment capital M1. So magnetic moment we have to take capital M1. Capital M1 capital M1 is suspended by a wire in a magnetic field. Is suspended by a wire. Is suspended by a wire. In a magnetic field. In a magnetic field. In a magnetic field. Next sentence. The top of wire is twisted through 180 degree. The top of wire is twisted through 180 degrees. Now, then the magnet is rotated through 45 degrees. Then the magnet is rotated through 45 degrees. 45 degrees. Next, under similar condition, another magnet of magnetic moment M2 under similar conditions, another magnet of magnetic moment M2 is rotated through 30 degrees. So what do you want to find? 30 degrees. Okay. The ratio M1 by M2 is, the ratio M1 by M2 is. So this already we have the formula for that, isn't it? Whenever a wire is twisted and magnet is going to rotate by 30 degree, we know we have M equal to C into magnetic moment M equal to C into theta minus alpha. That is our formula. So what we want here, M1 by M2. That is how much? C is same in both cases. So C into 180 minus 45 divided by C into 180 minus 30. Right. So that is first angle. So it is now 180 minus 45. So 135 degree divided by 150 degree. Am I right? Or radians we have to convert into radian. So we have 135 into pi by, of course ratio will be same only, and 150 into pi by 180. Okay, this gets cancelled. So what is our ratio now? What is the ratio? 135 by 150 divisible by 15. So 9 by 10. So ratio is 9:10. So that is, we can write 9:10. Okay. So that is the ratio. So these are some of the model which are very important for both NEET and NEET as well as MSET and JEE Main also. Okay. So tomorrow we will take up and one more important topic, that is magnetic materials. Then after that we will solve more problems based on complete chapter. Okay.